This is a review of the class session on May 1st of 2020. So if you attended the class session, you may not need to watch all of this, or you can skim through it, but this hopefully will work for the people that weren't there. So before you watch the video, be sure that you watch these videos I asked you to watch yesterday. So the first one has to do with rates of chemical reactions, and there's a teacher that goes through several little illustrations of how reactions occur. Of course, you also have a commercial since it's on YouTube, and he's trying to monetize this probably. But anyway, there you go. That's a series of chemical reactions, demonstrations that illustrate factors that affect reaction rates. So watch those first. And to summarize what those factors are, I thought I'd just write them. I'm going to try typing on this video because it might make it a little bit more clear. So factors that affect reaction rate. Okay, the first one is the nature of the reactants. What that means is that some molecules are more complicated than other molecules, and it takes longer for the more complicated molecules to react. So if you have to break and form multiple bonds, reactions take longer. Okay, that's the nature of the reactants. Now the second thing that he mentioned was the, I don't know if it's in the same order, but another factor that he mentions is temperature. So temperature would cause it would affect the number of collisions. In order for reactions to occur, they require that molecules come into contact. So in order for them to come into contact, they have to be moving, of course, and the faster they move, the more contact there is. So faster movement equals more contact. So if you raise the temperature, they move more, they hit each other more, and so they react. I can't say that I've got to deal with one other thing related to this. So parenthetically, contact must occur with sufficient energy and with proper orientation, which means that the molecules have to collide like this. So if a chemical reaction involves two molecules coming together so they fit together like that, then that would work. But if the molecules are oriented like this, then the reaction wouldn't occur because they aren't oriented properly to slide together. So the chemical reaction has to have energy to collide, and they had to be oriented properly. Okay, the third factor that was discussed in the videos was concentration. All right, so the analogy I usually use with that is if you have 5 people, scenario A, 5 people in a car versus 20 people in the same car. In which case would there be more contact? So more contact would be the 20 people. So in chemistry, it's kind of the same way. If you have more molecules in the same amount of space, they're going to bump into each other more. The fourth one is, the fourth factor was surface area. So surface area makes things more exposed. I'm going to draw a quick little picture for that. So let's go over here. So if you look at a cube like this, and you're trying to react with it, you could attack it from the outside. But if you broke the and you could do that all the way around. But if you broke the cube down into smaller pieces, and these are little sections of the cube that we have on the left over here. Now, here, bottom, top in this case, if that cube was sitting right in here, I've just exposed 1, 2, 3, 4, 5 more surfaces. So there's a lot more surface area when you have smaller pieces, and more surface area means more contact. And that is why things that are powdered burn real fast, and things that are not powdered don't burn as fast. Or that is why powdered sugar dissolves in water way faster than cubed sugar does. Okay, so surface area is the fourth factor that affects reaction rate. And the fifth factor is catalysts. They provide an alternative pathway for a chemical reaction. And that's a pathway that requires less energy. All right, so to illustrate that, remember these reaction curves. Looks like that. Okay, so this is enthalpy. Okay, enthalpy, this is time. So the change in enthalpy here would be that you're losing energy. You're starting here with reactants, and you're ending with products over here. So as you move from here to here, energy is lost. But you still have to provide this energy to get it started. So if you think about a match, striking a match, this is the striking of the match. Then the match loses energy. You know that because if you put your hand by the match, it burns your hand. But you have to strike it to get the reaction to start. So what a catalyst does is it creates a different way to strike the match, if you will. And it takes less energy. So since it takes less energy to get it started, the reaction will go faster. So that's the idea of a catalyst. In your experience in my class, we've done this reaction where we have the decomposition of hydrogen peroxide to create oxygen. That's where we put a burning or a glowing splint in a test tube, and the splint relit in the lab we did in class. So to make that go faster, we put this little black powder in, which is called manganese dioxide commonly, or technically it's manganese 4 oxide. And that catalyzes the reaction, although it's not used up. You can use it again and again. We use that again, this reaction, another time in our class in the pipette rockets that we did, where we were trying to shoot the little pipettes across the room. All right, so factors that affect reaction rates, there they are. I'm going to stop the video here because it's getting kind of long, I think, and I'll post this one and we're going to go on to part 2 of today's class.